What do you notice? I would like you to please take a moment and pause this video and ask yourself, what are you noticing that all 9 of these polynomials have in common? Now that you've had a moment to take a look at this, hopefully you've noticed that in all 9, they're all getting subtracted, and every value that you see is a perfect square value. These are called difference of squares. We're going to go to Brooke and Sophia to give us an idea of what it means to be a difference of squares. You have to have a perfect square in the first term. You have to have a perfect square in the second term, and these 2 terms have to be getting subtracted. So it would look something kind of like this. Thank you, Brooke and Sophia. Knowing what difference of squares looks like, now we need to know how do we factor them. So difference of squares is some value squared minus a different value squared. We factor it with the square root of the first value plus the square root of the second value times the square root of the first value minus the square root of the second value. So we've got an example of what that looks like down here. From here, we're going to do some examples of our own. I have a difference of squares, m squared minus 25 squared. What I need to do is I need to take the square root of this term and the square root of this term. The square root of m squared is m. The square root of 25 is 5. So I'm going to have m plus 25, m plus 5, m minus 5. This one, another difference of squares. The square root of 4g squared would be the square root of 4 is 2, and the square root of g squared is g. And then I need the square root of 100, that is 10. So I would have 2g plus 10 times 2g minus 10. Lastly, the square root of 16x squared y squared would be 4xy. The square root of 49 is 7. So I would have 4xy plus 7, 4xy minus 7.